Hello, this is the second video in a two-part series on molarity, molality, and mole fraction, and we're just going to go through a couple more examples. This is chapter 11.4 in the book that Chem 104 is using. So this is just from the first presentation. I wanted to put it here. Just remember that we're working back and forth between the different ways to express concentration. It's helpful to remember in our head what the symbols stand for. So we'll see that in our examples. Okay. So calculate the mole fraction of the solute and solvent in a 3.0 molar solution of sodium chloride. Okay, so the first thing that I'm going to do is I'm going to write down what this little m means. So I'm going to rewrite this as, hold on. Is we have a 3.0 solution, and this is moles NaCl, sodium chloride, per 1 kilogram of water. Right, this is an aqueous solution. Okay, so the first thing, like we talked about in the previous video, we always want to make an assumption. I'm going to assume, so my assumption here, 1 kilogram of water. So that means that we have 3.0 moles of sodium chloride. Okay. So if we make that assumption, now if we want to get a mole fraction, again, that's going to be, our mole fraction is the moles of our solute or our solvent for the divided by the total moles in the solution. So now we have our moles of sodium chloride. We need to calculate moles of water. So we have 1 kilogram. I'm going to put this 1.0 kilograms. The first thing that we want to do is we want to do a unit conversion and convert this to grams. So we have 1 kilogram here. There's 1,000 grams in a kilogram. And then we want to multiply by our molecular weight of, or we want to convert this grams into moles. So we want to convert 1 mole is 18.02 grams. This is for water. Okay, so this will give us our moles of water. And we only had 2 sig figs here, so we want to keep this in 2 sig figs. This calculates to, if we round it, this is 55 moles of water. Okay, so we have a total moles is equal to our 55 of water plus our 3 from sodium chloride, which is equal to 53.0, 58 moles total. Okay, so now we're in a position where we can calculate our mole fraction. We have all the information we need. So if we want to calculate our mole fraction of sodium chloride, this is going to be equal to 3 divided by our total moles, which is 58. And that is equal to 0.0052. And if we want to calculate our mole fraction of water, same thing. We're going to do our moles of water over our total moles. Our moles of water was 55, and our total moles was 58. And when we do that calculation, we get 0.95. Okay. So again, the key here was to assume that we had 1 kilo of water. In this problem, we have something that's 13% solution of potassium carbonate by mass, which has a density of 1.09 grams per centimeter cubed. And we want to calculate the molarity of the solution. Okay, so again, I'm going to write down here, we're looking for molality, and this is the units on molality is going to be moles of solute per kilograms of solvent. Okay, so we need to calculate both of those. Okay, so this is, we know we have a 13% by mass. So here my assumption is I have a mass of 100 grams. If I have 100 grams, well, 13% or 13 grams is my potassium carbonate. And the other 13.0, the other 87.0, this is just 100 minus 13 is water. Okay, so this is grams, right? We can multiply this times a conversion factor of 1 kilogram per 100 grams, 1,000 grams, sorry. This is 0.087 kilograms, okay? So that's my kilograms of solvent. This is H2O. That's my denominator here. So we have that bit of information. So now we need our moles of solute, or that's our moles of potassium carbonate. Okay, so we know we have 13 grams, 13.0 grams. And we're going to multiply this or by a conversion with the molecular weight, or the inverse of the molecular weight. So 1 mole molecular weight of potassium carbonate is I can't read my own handwriting, 138.21 grams. Okay, so this gives us 0.0941 moles of NaCl. Okay, so now we need moles per kilogram of solvent. So we're going to do 0.0941 moles of sodium chloride per 0.0870 kilograms of water. And this gives us 1.08 mole solution. Okay, so I think the key where people get stuck is what to assume. You kind of have to look at the information that you're given to decide what it is here. So 13%, whenever I have a percent of something, whether it's a mole percent or a weight percent, we want to, or a mole fraction or a weight percent, we want to choose something that like kind of makes that calculation easier. So whenever I have this percent, I usually start with 100 of whatever it is. So by mass, my mass was grams. Okay, once you get that, things and remember and think about here what you're calculating in terms of not just like your symbols like a big M or a little m or a mole fraction X, but what that really means, things start to fall into place. So we are here at the Tutoring Center to help all RVCC students. You can, if you've found this video, you found our YouTube channel, you can just search how to find appointment, and there's a video on how to make appointments if you don't know how to do that. But we're here to help. We're doing virtual appointments via Zoom. So you can check that out if you need additional help. Oops, that is not what I wanted to do. I'm sorry. And just finally, the slide template is from Slides Carnival.
All you have to do is follow a few simple steps.
Okay. Sorry about that. By the Slides Carnival, and the example problems are from the textbook that we're using this semester, which is Chemistry Atoms First, Second edition, available on OpenStax in electronic version.